Cloud.
So,
Hi, Caroline, Catherine.
Hello.
just working out, there you are, okay.
Can you all see me?
Hi, Riqui.
So, Ricky, do you share your screen? And
Yes.
Yeah, I'll share my screen.
Yeah,
Maybe we turn the front light off. It's a bit
so
light.
that's the function light. Yeah, okay, cool.
Can you see the slides?
Yes,
Awesome.
So here, please, everybody.
thank you.
Over to you, Riqui.
Okay. Good morning, everyone. I'm Riqui. How are you today, this morning?
Okay.
You're talking to an enthusiastic room of about 30 people here, Riqui. We've been here this is the second day, and we're really looking forward to hearing from you.
Awesome. Nice to meet you all. So I'm here today presenting my research topic, that is management and valorization of composite waste in New Zealand. So last year, I had the launch presentation at CANZ 2023 conference in Auckland. And today I'm excited to share with you the progress we have made and the conclusion we have drawn. So let me start by sharing a bit of background for myself, for those who haven't seen me before. Basically, I have worked almost 10 years in the construction industry, and I have growing interest in sustainability. I'm now a project manager for New South Wales Public Works based in Sydney. I oversee the construction of the first and second building at the new Bradfield City near the new Western Sydney Airport. I also worked 7 years as a QS in the construction field in Auckland. I delivered major projects, including the procurement and construction of the $40 million five-star Park Hyatt Auckland hotel. Throughout my career, I have grown interest in environmental management and waste management, which led me to pursue a master's degree in sustainable resource recovery at University of Auckland. So I wanted to make meaningful impact and collaborate closely with the industry. So when choosing the research topic, I discussed the potential with my supervisor. Throughout this conversation, I was introduced to CANZ and given the opportunity to contribute to CANZ's transformative project. Over the past year, I have worked really closely with Catherine and Glenn to understand the challenge and find a solution for composite waste management. We have gained valuable insights and found a clear pathway to implement these challenges. To implement the strategies effectively within New Zealand's unique context. So I want to take you through the key outcomes of the research and discuss how these findings can be translated into practical applications that will benefit our industry and environment. So composite materials are often praised for their strengths and durabilities. These qualities make them highly sought after in high-performance industries. However, they become really an environmental problem once they reach end of life. They're very difficult to dispose of because they are non-biodegradable and require specific process to break down. We recognize the urgency of the issue and wanted to develop sustainable management strategies that is specifically tailored for New Zealand. So throughout the presentation, I will tell you the composite waste landscape globally and the landscape in New Zealand, and I will explain the research objectives, the research methods and designs. I will introduce the latest innovations in recycling technologies that we have been exploring, and I will contribute with some strategic recommendations. So if we look at the global context, it's essential to understand the dynamic of the composite market and their implications for waste generation. So the market for composite materials is growing significantly from around 100 billion US dollars in 2019 to 112 billion dollars by 2020. That's the expected figure. Consequently, there is a significant byproduct waste, by 2025, we're looking at around 683,000 tons of composite waste each year. So industries such as aerospace and automotive are particularly impacted. These sectors rely heavily on composites for critical parts such as turbine blades and vehicle parts. So globally, some countries are leading, for example, implementing proactive legislation to manage this waste sustainably. So we can see a variety of legislative responses by different countries. In Germany, there is a ban on landfilling waste containing over 5% organic content, which includes wind turbine blades. For Netherlands, the approach is somewhat flexible. While landfilling of composite waste is banned in principle, however, the expectations are made if recycling costs exceed €200 per ton, balancing economic and environmental considerations. France has set specific recycling targets for end-of-life wind turbines. They require a minimum of 35% of rotor mass to be reused or recycled from July 2022. So this figure escalates to 45% by January last year and 55% beyond January next year. So in China, the legislation is comprehensive. So in China follows the rules of the end-of-life vehicle recycling regulations in 2001. There was amendment made in 2020 to the Solid Waste Environmental Pollution Prevention and Control Law, so that imposed stricter rules on production, storage, transport, and disposal of solid waste, which includes composite. And finally, for us, New Zealand, currently we lack of specific national legislation targeting for composite materials directly. Instead, the focus is on broader waste management strategies under the Waste Minimization Act 2008. So this act emphasizes reducing waste and improving resource recovery. So now we want to take a closer look at composite waste right here in New Zealand. So the recent CANZ survey have a result showing that our industry is generating around 190 tons of production waste each year. While this number seems relatively small, it actually highlights there is significant opportunities for us to push towards with more sustainable waste management practices. So I think we are at a turning point towards adopting a circular economy. The industry is ready for to shift away from traditional disposal methods towards a more sustainable practices. So one exciting area of interest we have seen is the use of cement cans for co-processing waste. Another valuable resource we have is our local experts in design and repair. By tapping into these skills, we can extend the lifespan of the products and boost their performance right from the start. Lastly, there is a real challenge for change at the local level. If our organizations began to document and share their progress towards circularity through case studies, it could serve as a blueprint and inspire broader adoption of the practices across the entire industry. And here in New Zealand, since we don't have a national strategy yet for managing composite waste, we can think differently. So we want to find the methods that meet the specific needs of New Zealand. So what makes a method suitable? So first, we want the technology to be technologically possible. So we're looking for advanced technologies that can be realistically adopted within the current infrastructure. It's all about making the most of what we already have. We want the technology to be commercially viable. Financial sustainability is a key. We aim to find a solution that not only work well, but can also stand on their own economically in the marketplace. We want the method to be environmentally appropriate. Each strategy we consider must align with our environmental objectives, that is, reducing the waste and minimize the use of non-renewable resources. We also want the method to be culturally appropriate because sustainability is about people and our way of life. The solution should respect our cultural values as well. And we also need to ensure that the recycling methods are accessible across various regions of New Zealand, so that is to promote widespread adoption and maximizing the impact. Lastly, we need the solution to be the right scale. It must match the actual volume of the waste we produce. So when designing our study, we set out to create a methodology that is robust and comprehensive. So we started with a holistic approach. This includes reviewing the existing literatures, engaging with the industry experts, and conduct data analysis. Next, we did technology assessment. Using the waste management hierarchy as a guide, we looked at 9 different technologies. By evaluating these technologies in a nonlinear interconnected way. So we were able to gain a comprehensive view of the potential each technology has held. And I will say the heart of the analysis was weighted scoring method. So we use this method to allow us to assess each technology on multiple criteria at different weight. Lastly, we tackled the barrier analysis. We needed to understand what might stop them from working. So since we have identified and analyzed the barriers, by overlaying them with the scoring results, we could find out how to overcome the obstacles. So here is a diagram that shows the waste management methods that could guide us, excuse me, in dealing with composite materials. So at the top of the hierarchy, we have waste prevention methods that including rethink and redesign products to minimize the waste. We have reduce and reuse materials wherever it's possible and repurpose them in innovative ways. And further down the hierarchy, there are recycling options that can be split into several categories. There are mechanical recycling, pretty straightforward and effective. That is, and then we have thermal processes like pyrolysis and fluidized bed methods. They're more energy intensive, but valuable for certain type of composite materials. We have chemical recycling, such as solvolysis and hydrothermal treatments. They break down composites for extraction of valuable components. We have electrical fragmentation. It's a size reduction approach using high voltage electrohydraulic and electrodynamic fragmentation. It is an alternative method to mechanical recycling. However, this method is very energy intensive. So last under the recycling methods, we have biological. Biological use biological agents such as enzymes or bacteria to decompose and transfer the composite materials into environmentally friendly byproducts. And then we have the recovery methods. This includes gasification and cement chemical processing, which converts the waste into energy and other useful forms. At the bottom of the hierarchy, there are the disposal methods, such as the incineration and landfilling. They are the least desirable methods due to the environmental impacts mainly. So we picked 9 methods from the map you have seen and put them in this table. We've compared these methods against total of 16 critical factors. These factors are under 4 aspects that are technology, economic, environmental and social aspects. So each method was scored from 1 to 9, 9 being the most favorable and 1 is the least favorable. So we didn't just put these numbers out of thin air. Each score is the result of rigorous evaluations based on extensive literature reviews and discussion from industry experts. We also introduced what we call a residual risk score. So this score flags any method that, despite an overall acceptable score, it might compose significant risk in certain areas. A residual score of 1 or 2 in any category signifies a major concern. This score indicates that the method falls substantially short of requirement, and it will not be mitigated or justified by the performance in other areas. So take, for example, mechanical recycling. It stands out with a very high score of 7.3. It highlights its effectiveness across every parameter. On the other hand, incineration and landfilling, they have significant drawbacks. So the method scores really low, especially in environmental aspects. So you can see the red scores of 1 or 2. Therefore, they are not recommended for New Zealand. So here we have this bar chart of the overall evaluation of different composite waste treatment methods. It clearly shows how each method performed across several key categories. This allows us to immediately compare their viability. So the result shows, of course, the highest score achieved is mechanical recycling with a score of 7.3. It is the most viable method due to the effectiveness, scalability, and adaptability for New Zealand. It is already widely used as a pre-treatment method for many other recycling processes. Therefore, it is the key part of any comprehensive strategy. And we also see that pyrolysis and cement can co-processing process as recommended methods. So they scored 6.9 and 6.65 respectively. Both have shown great potential, but there is room for improvement in emission management to make them more environmentally friendly. So while gasification and fluid as bed methods show some promise, they require further technology advancements to be more effective and manageable from emission standpoint of view as well. So these methods are not quite yet, but they could be a important role in the future. On the other hand, methods like solvolysis, electrofragmentation, incineration, and landfilling, they fall short in the key areas, especially in terms of cost and environmental impact. So the lower score highlights significant drawbacks, and as we mentioned in the last slides, the residual risk scores for this method further indicated that they're not suitable for New Zealand at this time of year. So since we have identified the most feasible methods for New Zealand, that is mechanical recycling, I wanted to show you an applied solution by the industry. This is Essodan Engineering's plant. This technology involves a very unique containerized system. It's called the plug and play. The container setup allows it to be deployed rapidly to any location around the world. It only requires one operator. The raw material enters the pre-shredder by the top loading conveyor belt and the feeder's arm, and it will move into the shipping container. So the process begins in the shipping container, process under negative air pressure for a dust-free environment. So this ensures operational safety and minimizes environmental contamination. So the plant can process around 1,000 kilos of material up to 1,500 kilos per hour. and it can transform them into granulated fragments ranging from 3 to 20 millimeters. Economically, the method stands out because it offers a practical, profitable solution. Moreover, the scalability and transferability of the plug-and-play system make it a game changer. So it can be adapted and used across different regions, also in various industry settings. So considering our geographical spread of the factories across New Zealand, and also we have relatively moderate value of waste that we produce, this model could be an ideal solution for our manufacturers. To conclude, I want to give you some actionable recommendations. First, we can prioritize enhancing our mechanical recycling infrastructure. The research has proven the benefits of the mechanical recycling. By upgrading our facilities, we can ensure that resources are recovered and reused instead of being lost as waste. We also could invest in pyrolysis facilities. It can help converting composite waste into recycled fibers. And the use of cement CANZ for co-processing is also recommended, taking the advantage of their ability to harness the energy content of resins and the mineral content of the glass fibers. We could also look beyond the familiar methods by promoting the research and development in other innovative methods, such as biological treatment methods, and investigating converting the waste into refuse-derived fuels, RDF. Additionally, we could develop a recycling code system. The system would identify and label different types of materials and waste, making it easier to sort and recycle at all stages of product life cycle. Implementing these strategies will need a strong collaborative efforts across our association, the government, the industry, and the research institutions. So I think it's all about taking the insights and turning them into a real on-ground actions that will make a real difference. So that's all for today. So for those who are interested in this topic, there is a 90-page full report that's available in University of Auckland's library. So it has the data analysis that will support my recommendation today. So at the end, I want to acknowledge to these people, they're including my professor, my supervisor, Saeed Baroshan, Catherine, Glenn, and of course, the Composite Association, my university, and the Circular Innovation Research Center. Yeah, that's all. Thank you.
Yeah, does anybody have any questions for Riqui while we have her on the line?
Yeah, Ricky, what are the markets for the byproducts of these things that are 3 to 20 mil? So we've taken big pieces of composite waste and turned them into small pieces of composite waste. Where's the market, or what are we going to do with that?
The market? Yes, so you can use the recycled materials. For example, we have seen the recycled material has been used for composite decking, for bricks, for construction, and there are so many different type of use that we can consider here.
So that one, sorry, Ricky, my answer to that is that's your job.
Yeah, it's really about looking for a new waste, like a new revenue stream, applying the recycled clean fibers for other use, give them a second life.
In other words, that's the next step for us.
Yeah, that could be the next focus. And like I said, it requires a collaboration with the industry and the association.
What is this ISO-DAN machine?
Where is it?
Yeah.
Mate.
Pardon?
It's they sell them at the moment.
Is that New Zealand?
No.
No.
This is Europe.
You go to Highpool and you get it for free. Wood chipper.
Yeah, it's been used, and we know it's been used in North America. One of the companies we discussed in the US is actually recycling 72 million pounds of wind blades at this point in time using that isodan equipment. So it's in the next step, really, you know. And the fact is, is it a composite association, or when I see our next step is we will start talking to recycling companies who've already got the infrastructure to move product around. So we need to bring them into the fray. What Ricky's identified is this is the correct method. It's pretty much followed what we found out with Finland. Work we investigate. They use it. I mean, Finland's quite a long country. It's the same population as New Zealand, and they've got the same. Well, basically, we see our problems the same as what they've done, and so as I say, Ricky's thing is to identify what is the right procedure for us to move and focus on and move forward on. Gut feel, Viv, I reckon we need 10% of what we recycle could actually be used today in all our products. It's the other 90%. What do we do with that?
It was interesting that they said bricks.
Yeah.
And that, so some time ago we had a job, and what we did is we hired a wood chipper, not the only one, chipped all the composite waste, mixed it with concrete mixer with a bit of resin, and turned it into big blocks, which were actually replacing concrete blocks that we used in let's say, a base isolator situation. Unfortunately, that didn't grow the way we wanted.
Yeah, but we have to look at other organisations, and you know, when I was working with Newplex, there was a company in New Zealand that was looking and investigating putting glass fibre into asphalt.
Yes. Yeah.
And that, so there's, you know, that's an area we can explore a bit, I think, down the track. You said concrete, cement, yeah, there's a lot of areas. But we've got to. Oh, sorry, Ricky, can you get is it on?
Yeah. I'm sorry.
Are you hearing me, Ricky?
Yeah, I can hear you.
So it's the next steps that we have to start formulate what we can do next. I mean, look, when we started this project, recycling, what, 5 years ago, and I always thought it'd be a 10-year project before we get to that final phase. There's a lot of work still to be done.
The quantities stated, 190 tons.
Based on the survey.
It's based on the survey. Obviously, there's two types of waste happening, isn't there? There's the stuff that we cut off in our factory and throw in the bin, but there's also basically every product that we make one day ends up as waste. And so hence why. Yeah.
I think you'll see a bit of this coming in Catherine's presentation.
Right, yeah.
Shortest life cycle is wind turbine blades.
Well, we're already seeing them pile up, aren't we? So, yeah.
I know where there's 97 of those waiting to be.
Pick them up Monday, boss.
So that's where I guess something like that
Ricky,
comes in, doesn't it?
Thank you very much. I think it was very clear and concise that you have brought a project so far to life.
Yeah.
I certainly, Catherine and I, have appreciated all the hard work you put into this.
Thank you.
Before we leave, is there any more questions for Ricky? Great, you can go back to bed.
Thank you again.
Thank you.
Very good.
Thank you all. Okay, bye.
Caroline, did we?
Whatever happened to
We're going to send it. Because we don't know where, we didn't know where she is or something.
adding the material into the resin chapter of the study at the uni?
Yeah, well, that's the back.
So we're next going to start